Problem number 763, partition labels. So this problem gives us a string S, and the goal is to partition the string into as many parts as possible so that each letter would appear in at most one partition. Right, so we also have to do it so that after we partition it and we concatenate everything, the result string would be S. And we have to return the list of integers, not the partitions, that represent the size of these parts, right, of these partitions. So for example, if you see here, right, this string, so we have A here, and if you want to keep the characters inside of this partition at most in this partition only, we would stretch it until the next A, right, and until we don't see any more A, B, C stuff, right? So after this, we don't see any more ABCs, which in this case will give you 9 characters. For the next partition, we will stretch it until we don't see all the uh, previous existing characters. So in this case, it will be 7, right? So it will be 7, 3, 4, 5, 6, 7. Yep. And then from this on out, so it will be, okay, so we have a J here. So the last J will be at the end of the string, which make this itself a partition, meaning that this length would be 8. Okay, so let's bring you through my solution. So for this case, I'll be using this example again, and um, should I make it? Yeah, let me space it out a bit so we can see it better. Okay, hopefully this will make it look a bit much better. I'll add a pointer to show where we're at. Okay, so my pointer would be like this. Okay, so this is my pointer. Just to not lose track because this is a long string. So that's my string. Here I have a hash map and a vector. So this is the result that we'll be returning. Here initialize size to the size of the string so that it won't call multiple times. Just a small thing. Here I have a for loop that initializes the map of a hash map. So here we have map. Okay, so first thing I do is I put in all the characters into the hash map. Okay, so this will take a while, but hopefully it won't be too bad. So A, there is a would keep the index. So this is 0, B will be 1. So A here, again, it updates to 2. So if you notice now, this hash map is storing the latest occurrence of the character. C is 2, this is 3, this is 4, this is 5, 6, 7, 8. Right, so 0, 1, 2, 3, 4, 5, 5, 6, 7, and 8. So that we have D at 9. Alright, so I'm assigning it to its latest position. D at 9, E at 10, F at 11, E updates to 12, G updates to 13, D updates to 14, E updates to 15, H updates to 17, I to 18, J to 19, H to 20, K 21, L to 22, I to 23, and J 24. Okay, so just to be clear, this should be 16, 8, 24. Yep, so 1, 2, 3, 4, and then we reach 24. Okay, so this is the hash map. Like I mentioned, it stores the latest occurrence of the character. So here I have an integer called previous. So this will store the previous maximum number. So we have max as well. Okay, I'll show you in a bit what those are for. But just know that we have a previous and a max. So here I'm iterating through the string again. Okay, so first things first, my max. So I'm looking for the maximum, or more like the furthest length, the furthest character. Okay, so max in this case would be the maximum of max itself, which is 0, and the first character, which is a. A is 8. So obviously this map is 8. And here I'm checking if I reach the maximum, if I reach the maximum occurrence of this particular partition, I will just create that partition with the size. But in this case, since I didn't, I move on to the next character, which is B. Alright, so B is 5. So obviously 8 and 5, the maximum is still 8, so we don't update it. Then we go to A again, still A, B. I should have a I counter here. Let me put I here. Right, so this I will be keeping track of where I'm at. So I right now is at 3. So B again is still 5. So 4. It's now C. So C is 7. 7 is still smaller than 8. So we don't need to change anything. Now we go 5, which is B again. 6, which is A, which is A, which is 8. A for 8. 7. C again. Okay. So here, since the okay, no, we have not reached yet. So C is 7 and 8, we get A, which is the last occurrence of this. Okay, so since here the maximum was 8, which means that this partition, the maximum occurrence of this of any character inside this partition is at index 8, which is over here. So what I will do is in my result, I would push back the maximum, which is 8, minus previous, which in this case previous was -1. So in this case, this will become 9, right? 8 minus minus 1 is 9. So what this means is previous is storing the starting index, and I just pushed in the length of this partition, which in this case is 9 characters long. 1, 2, 3, 4, 5, 6, 7, 8, 9. Once that is done, I update previous to our current index, which is 8. And I repeat the steps again. So now max, we look at 9, which is D. So D, the first occurrence is 14. So 14 is now bigger than 8, so we update our max. Then we go 10, and we're looking at E. E is 15, so we update our max. We go to F. F in this case is 11, so we don't need to update because 15 is the furthest, right? You see E is the furthest one. So if you go to 12, same thing, we still reach E. 13, we go to G, and G in this case is 13. Alright, don't do anything here. Then we go to D. D is 14, so 14 is still smaller than 15, so we don't do anything there. So 14, we go to E. Is it 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 3, 4, 5. This should be 15 actually. So at 15, we reach E, right? So this means that we have reached the furthest character in the partition, which is the character E. And since we have reached it, so meaning that this is a partition in itself, right? Sorry, from E to D. Okay, so what happens now is, again, since they are both the same, right? Max is 15, I is 15. So I push back the maximum minus previous. Right, 15 minus 8, we will get 7. Right, minus 8, 7. Yep. Okay. Then we update previous to 15 and we continue. So 16, we go to H. So H in this case is 20. Then we go 17, which is I. I is 23, so we update max again. 18, which is J. J is 24, so we update max again. Go to 19, which is H, yep. H is 20, don't need to update. So 20. Oh, sorry, this should be 21 now. 21 is K, don't need to update there. 22, we get L. 22, 23, we get I, last occurrence of I. And at 24, we get J, right? The last occurrence of J. So when this happens, I and max are the same. So we push back the result. So this will be 24 minus 15. This will give us 8. 24 minus 15. Okay, this should be 16 actually. Right, the previous was max. Should be 15. Right. Let me count again. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Yeah, 15. Okay, so 24. Should this be 24? 15, 16, 17, 18, 19, 20, 21, 22. Oh, so this should be 23, sorry. J should be 23. Yep, I have reached the end. So I has now moved to 24. Oh my god, I messed up everything. But you know how it works out basically, right? So we have 23 here, and when 23 minus 15, we will get 8, right? So J should be 23, it should be 22, but yeah, I messed up by 1 because of my counting. But you kind of get how it works, right? And the end result, after we've iterated through all of the string, we will get the result, which in this case is 9, 7, and 8. Yep, which is 9, 7, 8, and that's it. That's how we got the answer. Okay, so let's try that again. This time hopefully we'll get it correct. Okay, so move my pointer back, reset the hash map. So E we will get 0, C is 1, 2, B is 3, 4, 5, 6, E is 7, C is 8. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. 0, 1, 2, 0, 1, 2, 3, 0, 1, 2, 3, 4, 5, 6. Yep, 6, 7. Should be D. D should be 7. Sorry. E should be 8. C should be 9. Almost messed up again. Okay, previous is -1, max is 0, result is empty. Okay, so once we have done with this step, initializing the hash map, so we initialize previous and max. So we start from the first character, E. So you look at E, E will now become the max, which in this case is 8. Right, after that we move by 1 to C. C in this case is 9. So we update max to 9 again. Then we continue through to 2, now 3, 4, 5. So as long as our I our index did not reach 9, we continue moving forward and updating it if it is bigger than our current max. Right, so 6, 7, 8. Okay, so E is 8, and when we reach 9, we will reach the character last known C. And when this happens, max and I are the same, so we push back the result of max 9 minus previous, which is -1. So this will give us 10. So when that happens, this for loop will end, right? It iterated through the entire list of the entire characters inside the string and return the result, which contains a 10. Okay, so that's it. That's my approach to this problem. That's all I have to show. Thanks.